85 horsepower. That's what Ford's Flathead V8 made when it rolled off the assembly line in 1932. Today, your average economy car makes twice that. But here's the thing. This supposedly outdated, breathing-restricted side-valve engine became the most important power plant in American automotive history. Hot rodders took this $50 junkyard motor and turned it into a 300-horsepower monster that could push a stripped-down Ford to over 150 miles per hour on the Bonneville Salt Flats. How did an engine that Ford's own engineers considered obsolete by 1949 create an entire industry worth billions today? Picture this. It's 1946. World War II just ended. Thousands of young men are coming home with mechanical skills, learned keeping bombers flying and tanks rolling. They've got money saved, time on their hands, and a need for speed that 4 years of military service only intensified. In junkyards across America sit millions of Ford Flathead V8s, pulled from wrecked cars and trucks. These engines cost less than a good suit. What these returning veterans did with them would change automotive culture forever. The Ford Flathead V8 wasn't just an engine. It was the accidental foundation of hot rodding, the birthplace of the aftermarket performance industry, and the reason names like Edelbrock, Offenhauser, and Wyand became legendary. This is the story of how the slowest V8 Ford ever built became the fastest thing on 4 wheels. To understand why the Flathead mattered, we need to travel back to 1932. The Great Depression had America in a stranglehold. Luxury car makers were folding left and right. Even Ford was hemorrhaging money. Henry Ford needed something revolutionary, and he needed it fast. His Model A was getting destroyed in the sales charts by Chevrolet's new 6-cylinder engine. Ford's response would be audacious: put a V8 engine, previously reserved for luxury cars costing thousands, into a car the average American could afford. The development was rushed and secretive. Ford's engineers, led by Carl Schultz, Ray Laird, and Emil Zorlein, had mere months to design, test, and prep for production. They chose a flathead design, also called an L-head, where the valves sat beside the cylinder rather than above it in the head. This wasn't cutting edge even in 1932. Overhead valve engines existed and made more power. But Ford chose the Flathead for 3 reasons. It was simple to manufacture, cheap to build, and reliable as a hammer. The first Flathead displaced 221 cubic inches. The block and crankcase were cast as one piece, a manufacturing marvel that kept costs down. The heads were simple iron slabs. The entire valve train lived in the block, protected and lubricated. Compression ratio was a modest 5.5 to 1. Output was 65 horsepower at 3,400 RPM. By 1934, improvements pushed that to 85 horsepower. The engine featured a 3.0625-inch bore and 3.75-inch stroke. The crankshaft rode on 3 main bearings. Later versions would get beefier. Cranks with 4 mains. Connecting rods were forged steel. The camshaft, mounted in the block, operated the valves through simple tappets. But here's where it gets interesting. The Flathead had one massive advantage nobody saw coming. That simple, overbuilt bottom end could take absolutely ridiculous amounts of abuse. The block was thick. The crankshaft was understressed at stock power levels. The 3-bolt main bearing caps were massive. Ford built these engines to run forever in delivery trucks and taxicabs, logging hundreds of thousands of miles. That durability would become the hot rodder's secret weapon. By 1936, something was happening at the dry lakes of Southern California. Kids were stripping down Model A's and Model T's, yanking out the 4-cylinder engines, and dropping in Flathead V8s. The Muroc Dry Lake, later Edwards Air Force Base, became their proving ground. These weren't rich kids. They were working-class guys who could buy a wrecked 32 Ford for $25, pull the engine, and have the basis for a race car. The Southern California Timing Association, formed in 1937, to bring order to the chaos of dry lakes racing. Their first meet drew 85 cars. Most ran flatheads. Speeds were climbing. Stock flatheads could push a stripped roadster to maybe 85 miles per hour, but racers were learning. They discovered that milling the heads increased compression. Multiple carburetors added power. Different camshafts changed the power curve. Then came the speed equipment manufacturers. Vic Edelbrock Sr. was first. In 1938, he designed an aluminum intake manifold that could mount 2 carburetors instead of 1. His first production run was 100 pieces. They sold out immediately. The Edelbrock slingshot manifold became legendary. It could add 15 horsepower just by improving airflow. Phil Wyand wasn't far behind. His drag racing manifolds featured incredibly long runners that looked like spaghetti but produced massive mid-range torque. Offenhauser created works of art, polished aluminum intakes that could handle 3, 4, even 6 carburetors. Kong Jackson developed ignition systems. Clay Smith ground camshafts. Ed Winfield became the camshaft genius, creating profiles that could turn a wheezy flathead into a screaming race engine. But the real breakthrough came from a young racer named Tommy Thickstun. He figured out that the flathead's biggest problem was breathing. Those side valves created a tortured path for air trying to get in and exhaust trying to get out. The combustion chamber shape was terrible for flame propagation. Thickstun started welding and porting heads, creating bigger valves and smoothing the passages. Then Barney Navarro took it further, creating aluminum heads with vastly improved ports. Suddenly, flatheads that struggled to make 100 horsepower were putting out 150, 200, even 250 horsepower. The numbers were staggering. A stock 239 cubic inch flathead from 1946 made 100 horsepower at 3,800 RPM and 180 pound-feet of torque. With Navarro heads, an Offenhauser triple carb manifold, a Winfield cam, and headers, that same engine could produce 275 horsepower at 5,200 RPM. That's a 175% increase. Some builders pushed further. The Pearson Brothers Coupe ran 142 miles per hour at Bonneville in 1950. Their flathead made over 300 horsepower using Arden overhead valve conversion heads designed by Zora Arkus Duntov, the future father of the Corvette. Let me put that in perspective. A brand new 1950 Oldsmobile Rocket 88, considered the first muscle car, had a modern overhead valve V8 making 135 horsepower. Hot rodders were pulling twice that from an engine design Oldsmobile's engineers would have called ancient. The technical deep dive reveals why the flathead could take this abuse. The block itself was a masterpiece of over-engineering. Ford cast it from high-grade iron with thick cylinder walls, 0.25 inches minimum. The deck surface was massive and well supported. The crankshaft, especially in the later Mercury versions, was forged steel with huge bearing journals. Main bearings were 2.5 inches in diameter. Rod bearings were 2.125 inches. Compare that to a modern LS engine. The main bearings are actually smaller at 2.45 inches, despite making 5 times the power. The valve train was the limiting factor, but also surprisingly robust. Valve diameter was restricted by the bore. 1.5 inches intake, 1.4 inches exhaust on the 239. The valves opened into a pocket beside the cylinder. This created horrible volumetric efficiency, but the valves themselves were under stress. They ran cool compared to overhead valve designs. Valve float didn't occur until 5,500 RPM, even with stock springs. Hot rodders installed stronger springs and could spin them to 6,500 RPM, unheard of for a flathead design. The combustion chamber was the real problem and the area where hot rodders made the biggest gains. Stock compression was between 6.0 and 7.2 to 1, depending on year. The flame had to travel from the spark plug around the valve pocket and across the cylinder. This led to detonation problems with high compression. The solution was running high-octane fuel. 100-octane aviation gas was common, and multiple spark plugs. Some racing flatheads had 2 plugs per cylinder. Cooling was critical. The exhaust passages ran through the water jackets, heating the coolant. Stock flatheads ran hot. Racers added bigger radiators, better water pumps, and sometimes ran straight water with water-wetter additives. Block filling, pouring concrete into unused water jacket spaces, was common on drag engines that only needed to survive quarter-mile passes. The oiling system was actually excellent. Full pressure lubrication to all bearings, hydraulic valve lifters on later models, and a high-volume pump. Hot rodders added high-pressure relief springs and better filters. Bearing failures were rare, even at double the stock horsepower. But here's what really mattered: accessibility. Every junkyard in America had flatheads. Every mechanic understood them. Parts were everywhere. A kid with basic tools could rebuild one in his garage. Compare that to the new overhead valve V8s from Cadillac or Oldsmobile. Expensive, complex, and rare. The Flathead powered the birth of organized drag racing. When Wally Parks founded the National Hot Rod Association in 1951, 80% of the cars ran flatheads. The Santa Ana drag strip's first official meet in 1950 saw flathead-powered roadsters running low 14-second quarter miles at 90 miles per hour. By 1953, the Bean Bandit's Streamliner was running 11.45 seconds at 122 miles per hour with a blown flathead making over 400 horsepower. The engine created celebrities. Ed Iskandarian, became famous for his camshafts. His 404 racing cam became the most copied performance part in history. Vic Edelbrock Sr.'s company grew from a garage operation to a $1 million business by 1950. These weren't just parts makers, they were innovators solving engineering problems Ford never imagined. The Flathead's influence went beyond just hot rods. It powered midget race cars, hydroplanes, and even aircraft. The Granatelli brothers famously ran flatheads with massive superchargers at Indianapolis. Their 1946 entry made 450 horsepower from 183 cubic inches, 2.45 horsepower per cubic inch, when Formula One engines made half that. Ford knew what was happening. They watched their obsolete engine become the darling of American youth culture. They even helped, quietly. Ford's parts department would sell you racing pistons, though they'd never admit they were for racing. The infamous 999 racing block was available over the counter, a specially cast unit with thicker mains designed for supercharging. But by 1949, the writing was on the wall. Cadillac's new 331 cubic inch overhead valve, V8, made a 160 horsepower stock. Oldsmobile's Rocket 88 was cleaning up in NASCAR. Chrysler was developing their legendary Hemi. Ford's own engineers were working on the Y block, an overhead valve design that would debut in 1954. The Flathead's days were numbered. Production ended in the U.S. in 1953. The final Flatheads were 239 cubic inch units, making 110 horsepower. Ford had built over 24 million of them. But the story didn't end there. French Ford continued making flatheads until 1990, yes, 1990, for military trucks. In America, the speed equipment industry the Flathead created was just getting started. Something had to fill the void. Chevrolet's new small block V8 arrived in 1955. It made 162 horsepower stock, but had overhead valves and responded to modifications even better than the Flathead. The speed equipment companies pivoted seamlessly. Edelbrock made Chevy manifolds. Iskandarian ground Chevy cams. The infrastructure the Flathead built now served a new generation of engines. But the Flathead refused to die. Vintage racing kept them alive. Nostalgic hot rodders wanted the look, the sound, the challenge of making power. The hard way. H&H Flatheads in California still builds them today. A properly built modern flathead with billet crankshaft, aluminum rods, and modern cylinder heads can make 400 naturally aspirated horsepower. That's from an engine design that predates radar. The cost of building a Flathead today reveals its impact. A rebuilt stock engine costs about $5,000. But a full race version? You're looking at $25,000 to $30,000. Original Offenhauser intakes sell for $2,000. Arden overhead valve conversions, if you can find them, go for $15,000. These aren't just engine parts anymore. They're mechanical art, pieces of history, symbols of an era when innovation came from garages, not corporate R&D centers. So what was actually going on here? Why did the Flathead matter so much? The Flathead democratized performance. Before 1932, if you wanted to go fast, you needed money, lots of it. Duesenbergs, Auburns, and Cords, with massive straight eights and superchargers, cost more than houses. The Flathead changed that equation. Speed became affordable. Innovation became accessible. A kid with mechanical aptitude and $100 could build something that would embarrass cars costing thousands. It created an entire ecosystem. The Flathead didn't just spawn parts manufacturers. It created magazines. Hot Rod started in 1948. It created sanctioning bodies, NHRA, SCTA. It created careers, Carroll Shelby, Mickey Thompson, Don Garlitz, all started with Flatheads. It created a culture that said modifying cars wasn't just acceptable, it was admirable. The engineering lessons were profound. The Flathead taught hot rodders about airflow, combustion dynamics, metallurgy, and forced induction. Mistakes were expensive, but educational. When someone's Flathead threw a rod through the block, everyone learned about bearing clearances and oil pressure. When detonation cracked heads, everyone learned about octane and timing. This wasn't theoretical. This was hands-on engineering education. Think about that for a second. An entire generation of Americans became amateur engineers because of this one engine. They learned to read micrometers, use slide rules, calculate compression ratios, and understand cam timing. The Flathead was America's engineering classroom. The cultural impact was even bigger. The Flathead-powered hot rod became a symbol of American ingenuity, rebellion, and the pursuit of speed. Movies like Rebel Without a Cause cemented the image. The Beach Boys sang about it. George Lucas immortalized it in American Graffiti. The Flathead wasn't just an engine anymore, it was an icon. Modern perspective makes the Flathead's achievement even more impressive. Today's LS engine makes 6.2 liters and 650 horsepower in Z06 trim. That's 105 horsepower per liter. The best naturally aspirated racing Flatheads made 400 horsepower from 296 cubic inches, 4.85 liters. That's 82 horsepower per liter from an engine designed when Herbert Hoover was president. Not bad for obsolete. Technology. The Flathead proves something fundamental about American automotive culture. We don't accept limitations. Give us an engine that everyone says is junk, and we'll make it legendary. Tell us it can't be done, and we'll do it anyway. The Flathead was never the best engine. It wasn't the most powerful, the most efficient, or the most advanced. But it was available, affordable, and infinitely modifiable. In American hands, that was enough. Every aftermarket performance part you see today, every cold air intake, every set of headers, every programmable ECU, exists because the Flathead taught us that factory specifications are just suggestions. The billion-dollar SEMA industry, the massive online forums discussing cam specs and dyno runs, the entire culture of modification and personalization, it all started with kids in California trying to make Flathead Fords go faster than Henry ever imagined. The Flathead V8 reminds us that innovation doesn't always come from the top down. Sometimes the most important developments come from the bottom up, from individuals with grease under their fingernails and big dreams in their heads. Ford gave America an engine. America gave it back as a culture. What's the oldest engine you've ever modified? Have you ever built something that the manufacturer never intended? Drop your story in the comments. If you enjoyed this deep dive into the engine that started it all, make sure to subscribe. We're just getting started exploring the machines that change the world. Until next time, keep those engines running, whether they're flatheads or not.